to talk about fun minerals and the geology and how to identify them in the field and at home. This will be really fun. I am pretty excited about this video. I wanted to do a video specifically on micas. Those are minerals that you find semi-frequently when you're looking around outside. Muscovite mica actually has like a lot of practical applications that you may not be aware of. For example, Muscovite mica is used in a lot of glitters. So if you're someone like me who uses like glittery eyeshadow, or you know, you do crafts with glitter, Muscovite mica may have been used in the making of your glitter if it's a natural glitter. So there are a couple different types of micas that are predominantly the ones that get talked about. There's Muscovite mica and then there's Biotite mica. It can be a bit challenging to tell the difference between these two, but I'm here to tell you how to do it. So let's jump right in. We will talk about Muscovite mica first. This is a beautiful, kind of insane example of Muscovite mica. Muscovite mica is a more potassium-rich version of the mica family. Now, micas in general, I suppose I should explain this first before I jump into the two distinctions, but the Muscovite term is kind of, it's like a generic sort of umbrella term for minerals that fall under the category of aluminosilicate minerals that form into sheets or plate-like organization. And you're gonna see that on this monstrosity of a piece of muscovite. You can see that it is super, super sheety and platey. This is really, it's not like specifically completely unique to mica, but mica is probably like the most recognizable phyllosilicate that I can think of. Phyllosilicates just basically mean that they form in the sheets or the plates. Phyllo, if you're familiar with Greek roots, means leaf. I learned this when I was making spanakopita with phyllo dough, and I noticed that phyllo dough was really terrible and difficult to work with, and I learned that like muscovite mica, it is very thin and in sheets, and it's named after leaves and how they would like stack leaves on top of each other, and they're very thin and delicate. So, fun fact, fun etymological facts. Anyway, muscovite mica is a felsic mica. This means that it's going to be a bit more silica rich, and it's going to come from magmas that are more silica rich. Muscovite is usually the more common mica that we're going to see. The reason, or what we can use to distinguish it, is that it's really kind of a silvery color that can gradient into a dark, into kind of a pale brown to a dark brown color. But you can see that, especially on the margins and on the top, it is like a really silvery, sort of a more clear mineral. I'll show you what the table looks like after I've been handling it. So just all these silver bits and things. So looking at this, we can notice a couple of different things. First of all, that it's got vitreous luster. It's a bit glassy in the appearance and how light refracts off of the surface. It also has perfect cleavage. And if you haven't seen our video on cleavage, that is totally okay. To put it really, really simply, it just means that it's going to form these really perfectly tabular and platey surfaces when it flakes off, essentially. Because you can see that a lot has come off of it, but it's still really flat on the surface. So Muscovite mica, the chemical formula is 2 potassiums, and then it is an aluminosilicate mineral. So it's potassium, aluminum, silicon, and oxygen. And again, these are going to come from more silica-rich magmas in the earth. They're called felsic magmas. And muscovite micas are generally going to form under less pressure and less heat than its counterpart, biotite mica, which we'll talk about in just a moment here. We'll switch gears and we'll put them next to each other. Unfortunately, I don't have a piece of biotite to rival this magnificent and gigantic piece of muscovite, but I have this little guy. So right away, we can notice some physical differences between the muscovite and the biotite. Biotite is generally much, much darker. It appears like a dark brown to a black. But you can still see that it forms these platey, sheety, little things. Yeah. Very official definition there. But as you can also see, the biotite is a bit harder. It's a bit sturdier than the muscovite mica. It's about half a degree higher on most hardness scale. Muscovite rests on a 2 to a 2.5, and then the biotite is a 2.5 to a 3. That's pretty close. Unless you have like really exact tools to measure hardness, I don't think that is going to be a super helpful way to distinguish between the two. Generally, and I always say this, my professors always told me this, color is the least diagnostic way to determine what a mineral is. However, it can be helpful in certain circumstances alongside other observations as well. So the key difference between these two micas is visually kind of the silverier, paler brown color to the very, very dark brackish black color of the biotite. Now, the biotite comes from much more mafic magma. It's also a phyllosilicate. It's also going to have that vitreous luster that the muscovite has. It also has perfect cleavage. However, it's going to be interchangeable with magnesium and iron, and then it's going to have this always bound kind of with the segment of chemicals that really muscovite is entirely made of. You can see that, that's really, really similar. But it's going to have slightly different proportions of these chemicals, and it's also always going to have some degree of magnesium and iron mixed in with it. And that's because the magma that begats biotite is much more rich in these materials. I'd love to do a video as well on like the magnesium, iron, and silicate contents in the crust. Those are really, really, really important chemicals when we're talking about mineral formation and rock formation in general. So yeah, very much remember these three. These are kind of the trifecta perfecta of mineralogy. They're very important. The other way to tell between the two micas is mostly going to be contextual clues. Because biotite comes from the more mafic, more magnesium and iron rich magmas and geologic circumstances, it's going to be found with more pegmatites and granites. Whereas the muscovite mica is generally, these are not always going to be the case, but generally speaking, it's predominantly going to be in metamorphic rocks like gneisses and schists. So biotite, while it can be in both the metamorphic and igneous context, you're generally going to see it with those pegmatites and granites, whereas the muscovite is going to be in general with the gneisses and the schists. So those are the two ways that you can tell these two minerals apart. This is a fairly obvious example that I'm choosing to show you guys just to illustrate the key differences between the two. It can be a bit tougher in nature to distinguish between these, but I find that generally muscovite also tends to be a bit larger. You can also see that there's kind of like some pseudo like hexagonal or tabular crystals that sort of form into the muscovite as well. Oh, hello. Look at that. Little piece of muscovite. So you can just see how clear and glassy that is compared to the biotite, which is very dark and black. So essentially the two ways to tell these apart are the context and the color. But I wouldn't encourage anyone to ever use one method of differentiating minerals or identifying minerals. I would always recommend people to use their entire lexicon and their entire toolbox that they have when they're looking at something in the field or at home. But yes, this has been a crash course on micas. You'll see them really commonly throughout the United States, and they're pretty fun to be able to look at and go, oh my gosh, I know what that is, that's mica. So hopefully after seeing this video, you'll be able to do that. So yes, I will do more spotlight videos on minerals and how to tell them apart from each other. These are super, super fun. If you guys have any requests, please let me know. Like and subscribe, and I'll see you guys in the next video. Thanks so much.